In this related rates problem, we are given several pieces of information, including a constant, two variables, and the rate at which a ladder is sliding away from a wall. The constant is the length of our ladder, that's 20 feet. The first variable is the distance the base of the ladder is from the wall in feet. We will call that distance x. The second variable is the height the top of the ladder is from the ground. We will call that distance y. We are also given the rate at which the ladder is sliding away from the wall, and that is 5 feet per second. We are asked to find the rate at which the top of the ladder is falling when the base of the ladder is 5 feet away from the wall. One thing that we are not given, but is very important, is the Pythagorean theorem. At this point, we are expected to know that x squared plus y squared equals z squared. Thank you, Pythagoras. In order to solve this problem, let's first put Pythagoras to work. We will use the x value of 10 feet, which is the distance the base of our ladder is from the wall, and the z value of 20 feet, which is the length of our ladder. Substitute these values into the Pythagorean theorem and solve for y. The height of the top of the ladder is from the ground, which is 10 square root 3 feet, or approximately 17.32 feet. Let's look at what we've got so far. The base of the ladder is 10 feet from the wall. The top of the ladder is 10 square root 3 feet from the ground. The ladder is 20 feet long. The base of the ladder is sliding away from the wall at a rate of 5 feet per second. This is our dx over dt value, or our change in x over time. Next, we will use the differentiation techniques we have been learning: the constant rule, the sum rule, the power rule, and the chain rule. We will be differentiating the Pythagorean theorem. First, we will substitute in the constant term for z squared, 20 feet squared. It is not time to substitute in the terms for x or y. These terms change with time. The length of the ladder does not change. Differentiate both sides with respect to t. We now substitute in our dx over dt value, that is 5 feet per second. This is a constant rate that also does not change. What we're left with is a general equation that can be used for any combination of x, y, and dy over dt values. If we know any two of these variables, we can easily solve for the other. So when we solve for dy over dt, we get negative 5 feet over square root of 3 feet per second, which is approximately negative 2.7 feet per second. Our final solution is, when our 20-foot ladder is 10 feet from the wall and is sliding at a rate of 5 feet per second away from the wall, the top of the ladder is falling at a rate of 2.89 feet per second. Thank you.